Good morning, everybody. Today I'll start class on oily water separation, some electrical and other background I'll give, and I'll finish the whole lecture course. Uh, so first I'll start with oily water separation. Actually, this is bilge water. Bilge water means at the lowest most position of the ship, there will be storage of water. So whenever any waste water is there, so there will be storage, and finally you have to dispose this one. And disposing directly into sea will have issue because MARPOL is there. They have some regulation. You have to follow the regulation. So once you are following the regulation, that means you have to do some mechanical, chemical or other arrangement so that you can remove the contaminants from water and you can dispose. In many cases you can transport to onshore also, and there you can dispose with proper regulation, following proper regulation. But normally when you are having big ship or you are going for long duration from one place to another place, so the volume of water will be higher. So higher volume of water you cannot dispose, you cannot carry, so you have to remove contaminants, then you can dispose in water, in ocean water. So the bilge location, if you see any ship bilge location will be like the lowest most position here, and bilge will be collecting all the water coming from your AC, air conditioning system, your machinery system, grease may be there, oil will be there, so many contaminant will be there. So that contaminant you have to remove, then you can dispose. So if you can see this is bilge well, and this is bilge well, and this is bilge water tank. Okay, and this one pump. So normally the bilge water pump will be like centrifugal type pump. Many other type of pumps also can be used, but most common is a centrifugal pump because it is easily available, cheaper, and it can handle larger volume, because here your target is not to produce high pressure, rather just transporting water from one place to another place, or adding certain amount of head. But in certain cases, for example, if you remember your pump lectures, if you need very high pressure development, there you need reciprocating and other type of pumps. But in this case your volume flow rate will be a little bit higher, but pressure development is not too high, so centrifugal pump is okay. But other type of pumps are also used, I'll discuss later. And once you got bilge water, you pump to some bilge tank. So bilge tank, you will be doing some chemical dosing. Chemical dosing means you add some chemical and you try to settle some contaminant there, or you try to separate the emulsion, oil and water emulsion, so that other mechanical or arrangement, they can separate oil and water properly with proper regulation as per regulatory mechanism, regulatory instruction. So then from there you can go direct, at the end you can go to nearby bilge water treatment system, maybe centrifuge, or maybe you will have like reverse osmosis system. You have seen your membrane system, so membrane system may be there, because you have to remove the oil content to a very low level. That's why you will have several stages of separation. First, maybe you just settle in tank, you store water in a tank, and you give enough time. So slowly water will be creating one layer at the bottom, and oil will be floating on the water surface. When what oil is floating on the water surface, you separately, you skim out that oil, and then again you send that water oil mixture, whatever remaining part, so to another tank, where you maybe have to add chemical to break the emulsion. Then once emulsion is broken, then you put to another mechanical arrangement, for example OWS, oily water separator, or centrifuge, or membrane system. So then you can separate. Once separation done, then you can dispose the water. And you can see right side one picture I have given here. So if oil spill is there, how it will look like in the ocean, and once it is spreading over a larger area, so it will be harmful for your environment. Oil spill occurs because of many reasons. One may be like say tanker overturning, or leakage in tanker, or maybe bilge water, not treating bilge water and you are disposing in ocean. So that sort of uh, reason can be there for this oil spill and environmental hazard. And bilge water, a mix of water and fluid that can be like oil, grease, okay, so hydrocarbon basically. and many aromatic aliphatic hydrocarbon will be there. So if it is aromatic hydrocarbon, then you have some detector, you can detect also how much percentage of hydrocarbon is there. And your oil and water, I'll be using the term O for oil and W for water. Okay, so oil and water mixture to 15 parts per million. So this level you have to reduce. So during desalination process, you have seen this definition of ppm, parts per million. Like seawater desalination, seawater will have ppm of 35,000 to 40,000 ppm, and you are reducing to 500 around ppm, 500 1000. But here oil content you are reducing further lower, 15 ppm. This is as per MARPOL regulation. Okay, I think you have write capital. MARPOL regulation. But if you see the Canada's regulation, Canada they have regulation, you have to reduce the content of oil 5 ppm. Okay, Canada is much stricter than international agency. So bilge is there at the bottom, nearby bottom of the ship. You have seen here, and here it is getting collected. Okay, so this is the name term is used as a bilge water. Sometimes we are using as an oily water mixture coming from your ship. Oily waste generated by ship amount to millions of tons annually. So huge amount of oil and water mixture is being produced every year because of lots of ships are running all over the world. So a mixture of water, oil, lubricant and other fluids. Some metals also will be there, small metal particles. Bilge water management, so retain it on board for later discharge ashore, reception facility, or treat it on board using bilge separator, oily water separator, or OWS. So the term OWS I'll be using later stage. Annexure 1 of International Convention for the Prevention of Pollution from Ships, so MARPOL, 1973, 73 by 78. They have regulation that if you have ship gross weight more than 400 gross tons, or GT, must install equipment to limit oil discharge into ocean to 15 ppm. Okay, all vessels more than 400 GT or gross tons must have an oil content monitor, OCM, with a bilge alarm integrated into the piping system. Oil content monitor will say, okay, your oil content is going more than 15 ppm or 5 ppm, whatever regulations you are following, then your alarm signal will be working and your bilge pump and other system will be working accordingly. If you are not pumping out this one, then everything will be flooded in that area. Again, the flooding and water can enter into engine room and other areas, plus this ocean pollution will be one issue. So you have to remove oil and you have to handle the water properly. So Canadian regulation for the prevention of pollution from ships and dangerous chemicals, they are saying 5 ppm, this criteria. This is very tight criteria actually. International says they are 15, but Canada says 5. Oil concentration in bilge water typically fall within 100 to 400 ppm. So you have to reduce 100 to 400 to 15 if you are following international standard. If you are using Canadian standard, then it will be 5 ppm. So bilge pump. So when you have bilge water, so you have to transport water from one place to another place, because during disposal stage or during your cleaning or removing of oil particle or contaminants, you need to pump or you need to give pressure or energy to the fluid, so that fluid can be given to your centrifuge or maybe OWS or maybe your filtration system, then you can pump it out. Okay, so bilge definition is a part of the hull that would rest on the ground or if the vessel were unsupported by water. The lowest compartment on a ship is on the either side of the keel and in a traditional wooden vessel between the floors. Common bilge pump, centrifugal or diaphragm pump, and reciprocating pump also can be used. Okay, so centrifugal pump, I already told the centrifugal pump volume flow rate will be higher. You can remember this head and flow rate characteristics. Centrifugal pump will have head and flow characteristics like this, and but reciprocating pump, this is centrifugal. Reciprocating, okay, and diaphragm pump also one type of reciprocating pump. So whenever talking about reciprocating, its speed is lower, so volume flow rate is lower, but your pressure development will be very high. But in bilge cases, normally our pressure development may not be required so high. So common use centrifugal pump, but other pump also can be used. And one Bilge pump got from a website Geomart. So like for example purpose, I have given 1100 gallon per hour electrical Bilge pump. Electrical Bilge pump can be used aquarium, fishing, many other applications also there, but this is also used for shipping applications. So the picture also shows this is a centrifugal type pump. Okay, so in India they are selling this pump, simple plastic type pump. Okay, reciprocating and diaphragm pump, lower capacity and cannot handle debris, while centrifugal pump can handle little bit debris also, and higher flow rate can be achieved using centrifugal pump. So Bilge separator, so Bilge separator, Bilge water separator, you can say a gravity OWS or oil water separator, OWS oil water separator. Okay, a gravity OWS, because of gravitational force the separation will be done, or a centrifuge can be used to separate oil and water with one or more additional unit of operation that polishes the bilge water, reduce the ppm to 15 or 5 as per requirement. Oil exists in free, dispersed and emulsified form. So oil, small amount of oil is there in water. Okay, so oil particle will be dispersed like this. Okay, so this is discontinuous phase or dispersed phase. Okay, and water, oil, and water continuous phase, because oil content is low. But in many cases, many other applications where oil content is higher and small water particle will be there. For example, oil and gas industry, they will be separating water from oil because their main target to get oil. So water must not be there. In that case, continuous phase will be oil and discrete phase will be water. But in your bilge water application, normally water content will be higher, so that is continuous phase, and small oil particle will be here and there, so that will be discrete phase. Okay, so discrete phase oil particle will not get separated easily. So if you can make larger particle, if you can make small particle combined together, then separation will be quicker. So later we'll discuss how this happens. Okay, oil exists in free, dispersed and emulsified form. Okay, so many time oil may not be emulsified, many time it will be emulsified form. So if oil is pure and water is pure, there is no contaminant, then water and oil, let's say if you take water and oil, okay, water and oil you take in a bottle and you shake properly, and within few seconds again water oil will get separated because there is no contaminant. For example, you take petrol and oil, if you mix it and if you keep for few seconds, it will be separated completely. Oil will be creating upper layer, water will be creating lower layer, because water density is higher, gravity is higher. Okay, higher gravitational force, and lighter, oil is lighter. So this is not related to viscosity, this is related to whether heavier and lighter. So water is heavier, so it will be creating lower layer. And if you have sand also, for example, or some heavy metal, so it will create lower layer. Okay, so sand will be much more denser. So sand density will be like 2.6, water density is 1, and oil density will be like 0.8 about. So oil density differs because oil will have long chain hydrocarbon, short chain hydrocarbon, and different types of oil will be there. So the oil density will be changing. Okay, but sand, normal sand application like around 2.6 density, and water density, you know already, 1 means 1 gram per centimeter cube or 1000 kg per meter cube, right? So sand will be like 2600 kg per meter cube. So oil will be like 800 kg per meter cube. So oil is lighter, so oil will be already floating. Now if you have certain amount of oil in water, small particles. Those particles will be try to slowly floating up because of buoyancy effect, and it will be creating layer on the top. Okay, so layer, oil layer. Okay, slowly oil will be creating one layer. So from the top, just you remove the oil, and again you give enough time the oil particle to move up. So you have to give enough time. So to separate oil with gravity separator. Gravity separator means you are not giving any energy, just you have one tank, and in tank you put all this oil water mixture. What will happen? Oil particle will be trying to moving up. Okay, water will be settling, then oil will be creating one layer here. Okay, so you have to give enough time. Give if there is no impurities or contaminant, then oil and water will be separating quickly. A few seconds it will take, unstable emulsion will be forming. But if there is any chemical, then it will be creating stable emulsion. So oil particle will not move or will not be able to move because of certain other hindrance effect on this one. Okay, so the enough time is called retention time. So how much time you are giving? So that is called retention time. So you keep for 15 minutes. So 15 minutes is your retention time. In 15 minutes, how much oil is getting separated, that you have to calculate. Later we'll see how to calculate this one. So units of operation here, OW is oil water separator, and yeah, so I'm discussing about this one, the gravity based separator. Okay, and there will be some non-gravity based separator, for example centrifuge. Centrifuge, this one you see the top centrifuge is non-gravity based. Non-gravity based, or maybe gravity will be assisting. Okay, because at high velocity you are creating that separation. So the unit operations will be like absorption, adsorption mechanism, biological treatment will be there, coagulation and flocculation, flotation, ultrafiltration. So we'll discuss that one also in short. So how to separate oil water before disposing the water into the ocean. So pure oil water, no emulsion form. Okay, unstable, separate in a few minutes or few seconds. Surface surfactant we'll discuss later. Surfactant means some chemical if you add, then the oil particle will not try to move because of this chemical effect. So surfactant will be creating emulsion, and because of emulsion creation the particle will not get settled. Then how to settle that one? Some techniques are there, we'll discuss. Disinfectant added to break the emulsion, or surfactant must be neutralized using disinfectant. So some chemicals are there, if you add there, then the emulsion will be broken, and again oil particle will try to get separated from water. So we'll discuss that one also. Emulsion. So Latin term emulsion is to milk out. Okay, so like milk, if you rotate very high speed, it will be creating skim, or butter will be separated from the milk. So from there the term came up. So normally emulsion will have two fluids. So not any two fluids, two immiscible fluid. Okay, two immiscible fluids are there, then you are trying to mix, and if you are creating emulsion, that will be stable emulsion. It will not get separated again. But let's say oil water, pure water you are taking, and both are immiscible, but if you don't have any other chemical, then it will be separating quickly. You are not creating emulsion there. Okay, that will be unstable emulsion, you can say. So immiscible liquids, unmixable or unblendable, plus surface active agent, emulsifying agent, we'll discuss later. So one liquid is here, let's say oil particle, and inside water. Okay, so oil particle will be moving because of buoyancy effect, moving up. Okay, but if you have some surface active agent around, let's say called surfactant or surface active agent. Surface active surfactant, surface active agent are there, then this particle will try to move, but it will be pulling it back. So it will not be separated. Some cases the emulsion will be so stable, several months also if you keep, it will not get separated. Okay. So dispersed and continuous phase. So dispersed already I discussed that, like continuous phase is water because larger amount is there. Dispersed phase is oil particle, the small particle here and there. So this is dispersed. Okay. So oil in water. So in our case, in our bilge water case, normally it is oil in water. So small amount of oil is there. Okay. Bilge water. So in our bilge water application, it is oil in water emulsion. Okay, but in certain other cases, water in oil will be there. So oil in water means our continuous phase is water. A discontinuous or discrete phase or dispersed phase is oil. Okay, but water in oil, there continuous is oil. Continuous phase. So here actually, although we are saying phase, but technically it is not phase, because water and oil both are liquid phase. So it many times we say component, same phase but different component. Okay, so although we are using phase, but instead of phase we can use component. Okay, so liquid component, a liquid has having two components, one is oil, one will be water. Both are immiscible. Okay, so stable or tight emulsion, oil droplets will not settle out from the water quickly due to small size and surface tension. Okay, so because of water is having surface tension and size, if particle size is very small, then water oil particle will not try to get out of the water oil particle. So in that case we say it is stable emulsion. Unstable emulsion means like pure oil water mixture, you just you talk in bottle, you shake it, so quickly it will get settled out. Okay, contaminant at the interface form a tough film or skin and impede or prevent coalescence of oil droplets. So coalescence means like I have one oil droplet, I have another oil droplet. If both are mixing together making bigger particle, it will be better. But what happens if I have emulsion? I have like say surface active agent, so pure oil, it will create bigger particle. But if you have surfactant, okay, so surfactant what will do? I have oil particle, so this will not make bigger particle. Okay, so why bigger particle is better? Later we'll discuss particle settlement term. So when particle is bigger, it will be sliding at higher rate, but particle is smaller, it will not slide. Okay, so our attempt will be to make bigger particle. So if I make bigger particle, that will be settling quickly. So our retention time in a tank, so if I have one settling tank, if I give enough time, let's say 15 minutes time, and particle very small, so particle is trying to move up, but before moving it again I have to remove water, I have to fix, I have to put more water. Okay, because our retention time is low but particle size is very low. But in some cases particle size is larger size means it will be moving at higher rate, so 15 minutes will be sufficient for moving water particle to the surface, so that we can skim out oil, water can be separated separately, it can be taken out separately. Okay, so we'll discuss later. Some stable emulsion may take weeks or months to separate. Pure oil water separates quickly. The stability of an emulsion depends on density difference, particle size. Okay, so like Vt proportional to density difference, delta specific gravity or density, particle size, okay, viscosity, and interfacial tension, presence of emulsifier. Emulsifier will not allow to mix separate, water salinity, age of emulsion, and agitation. Agitation means if you are stirring very high rate, then actually you are creating very small particle. Very small particle will not separate quickly. You have to make bigger particle. So if you are trying to make bigger particle, then okay. But if some pump is working, pump will be creating very small particle, or if any other machine is working, very small particle you are creating, then things will not work for gravity settlement. Okay, gravity settlement you have to make bigger particle. Again, if you have emulsifying agent, you have to remove that emulsifying or surfactant. If you are removing surfactant or neutralizing surfactant or removing emulsifying agent using some chemical or other mechanism, then again settlement rate will be very high. So Vt actually your settlement velocity. Okay, if density difference high, settlement velocity high. Is dm particle diameter. Which particle? Oil particle diameter. So oil particle diameter higher, settlement is higher. Viscosity. Viscosity means fluid water viscosity here, not oil viscosity. Water viscosity. Okay, water viscosity anyway, it is, we cannot change much, but in other case, for example, water in oil case, oil viscosity can be changed. Okay, so in that case viscosity also plays a very good big role, but in oil, water case normally viscosity will not change with small temperature changing. Okay, so terminal velocity or settlement rate will be higher if have high density difference. Water and oil density difference is very high, settlement rate will be higher. For example, oil density and water density same, then both will not get settled. But oil density very low and water density almost fixed, then the settlement rate will be higher. Again, particle size diameter dm or oil particle size diameter is higher, is settlement rate also higher. And this is for your gravity based separator. If you are having only settling tank, one tank, and you are putting oil water mixture and you give say half an hour, 1 hour time, so slowly oil particle will be moving up, it will create layer on the top. Okay, so in that case higher, larger oil particle size better, density difference oil and water better. And again you have to consider that no emulsifying agent should be there. If emulsifying agent is there, then whatever time you give, it will not get settled. Okay, so then in that case you have to add some other chemical to neutralize the emulsifying agent or deactivate, then again your settlement will be starting. So emulsion breaking by 4 mechanism. Okay, so emulsion, let's say I have one emulsion here, I have oil water mixture, this oil particle is here, water and oil particle. Okay, so distributed. Now next is flocculation and coagulation. So what will happen, initially before separation the particle will be nearby together. Okay, so this is called flocculation and coagulation. From there it will happen, it will make bigger particles. Okay, few particles will be joining together because you are removing, you don't have maybe surfactant or you neutralized, then particle will be coming together, it will make bigger particle. Okay, so this is called Ostwald ripening. Okay, it is making bigger particle. Then from bigger particle it will create creaming. Creaming means particle will be bigger, so it will be trying to moving up. Okay, so it will try to move up. So this is called creaming or sedimentation. Sedimentation. The next is making bigger particle there. When particle move top, so this will be making further, so it will be making one layer D. So this is called making bigger particle, making oil layer. So finally it will create two separate layer. One will be oil. Okay, so first part is that you have to bring the small particle nearby together, then it will be colliding. If there is no surfactant, then collision will be occurring, there will be no barrier between them, then they will be joining. It will be like this. So one particle is here, another particle is here. Now because of agitation or some motion, the two particles will try to touch each other. When it will be touching, it will be creating like this. Finally it will be creating a circle sphere. So normally the oil particle will create a complete circle because of surface tension. Okay, sphere. Okay, because of surface tension, because surface tension says that particle will try to create lowest surface area. Okay, so lowest surface area means spherical shape will have the lowest surface area. So particle will make spherical shape. So emulsion stability, unstable phase separation immediately. Unstable phases separate immediately. Then it may be like few seconds. Okay, within few seconds it will be happening. But if you have stable, so it can take 1 hour, 2 hour, days or weeks. And in many cases emulsion will be so much stable that no visible sign of phase separation after 2 weeks also is possible. So I said like emulsifying agent or emulsifier. Agent or emulsifier or surfactant. Okay, the same thing with different names. So surface active or surface active agent or surface active agent, they'll say. Some agent will be preferring oil, some surface active agent will be preferring water. Okay, insoluble in one phase. So emulsifier will have insolubility in one phase and other phase it will be soluble. Thus it concentrates at the interface. So emulsifier or surface active agent, it will be interface. Like for example, oil droplet is here and it will be concentrating so it will be creating like this. So many emulsifying molecules will be creating one leg, one head. So this is your head, hydrophilic, and the tail part will have hydrophobic. Okay, so emulsifying agent, it will have two end. One end is hydrophilic end, head, hydrophilic, hydrophobic tail. Hydrophobic. So hydrophobic part will be entering into oil molecule, oil particle, and hydrophilic part, it will be around the surface. So it will be creating one almost layer around the oil particle. Okay, so this way it will not allow two oil particle to mix each other. So I have another oil part, let's say one oil particle, one oil particle, one layer, another layer of surfactant is there. So both will not allow to join together because already hydrophilic end is there. Okay, so it will not mix together, it will not make bigger particle. But if I can remove that part, then it will make bigger particle. But in other case, if I say this is oil in water. Okay, but if I have water in oil, say water in oil, So in that case, so head part is here, this is water droplet. Okay, so head part, hydrophilic. So hydrophilic, philic means loving, hydro loving, water loving. So water loving area will be inside droplet, and outside hydrophobic, this one. Okay, those molecules will be aligned like this way. So again, two water particle will not mix if it is water in oil. So water in oil also, two water particle not joining together, so settlement rate will be lower. In oil case, oil particle case, in oil in water, two oil particle not mix together, they will not make bigger particle, so settlement rate will be very low. Okay. So polar molecules in such a way, align such a way that they cause an electrical charge on the surface of the droplet. An electrical charge repels two droplets must collide with sufficient force to overcome this repulsive force before coalescence. Some emulsifier, so for some example emulsifier you should remember, like emulsifier or emulsifying agent, paraffin, resin, organic acid, metallic acid, salt, corrosives, clay, asphalting, your detergent also emulsifier actually. Detergent, example is here, detergent interacts with oil and water, stabilize the interface between oil and water droplet, so it will create a stable emulsion. So demulsifier, when you have emulsifier, you know, so then you have to add certain chemical which is called de-emulsifier or emulsion breaker or demulsifying agent. Okay, it will be inactivating your surface active agent. So emulsion can be broken thermally or chemically. Demulsifier neutralize the effect of emulsifier. Four important aspects of a emulsifier: attraction, oil water interface, flocculation, coalescence, solid weighting. So these things the demulsifier will be doing. The demulsifier rapidly migrates through the water to the droplet interface, attracts similar droplets, create a large cluster of droplets, neutralize emulsifier, rupture droplet interface. So droplet is there, so you have this one emulsifier, this is emulsifier. Okay, so emulsifier, first you have to they will neutralize, remove or rupture this surface layer whatever this emulsifier created. So demulsifier will be removing, neutralizing, removing, then they will allow to coagulate or meet each other and make bigger particle. Okay, so first thing, surface, removing surface barrier. Demulsifier removes surface barrier, make bigger particle. Gives sufficient time to meet and separate, and low agitation. Okay, so why low agitation? Because if you have large agitation, again a big particle can be broken. So if big particle broken, again separation will be difficult. So give lower agitation so that particle will be moving. So give agitation maybe if needed certain amount, so which can be helping you. But if you are giving too much agitation, maybe some particles trying to moving up because of water turbulence, the same particle will be going below also, or the same particle will be broken because of turbulence. So do not give so much agitation that particle will be broken, or that particle already moved up, same particle should not go back to the bottom. Okay, so that you have to take care. Okay. Okay, thank you very much for today's lecture. Next day we'll start, we'll continue this topic. Thank you very much.